All right, welcome everybody to week 15, day 1. This is not a full lecture. I'm just going to show you guys some common mistakes that people make, and maybe those mistakes are the mistakes you made on the Pokemon assignment. And I'm going to give you a little bit of time, not a lot of time, a little bit of time, where you can try and fix them so you don't get a 0 or whatever. So let's do this. Vim main.cc. So first problem I saw was people did this, and stab equals 1. What's the problem with this, everyone? Because they had the code that said if the type is equal to Pokemon type 1, or type is equal to Pokemon type 2, then stab is equal to 1.5. Stab is the same type attack bonus. It's supposed to be 1.5 if your moves type, like let's call this move.type. This isn't real code. Move.type equals Pokemon.type, or move.type equals Pokemon type 2. So if the type of the move matches either of your two Pokemon, and that was another mistake a lot of people made, they were only checking against the first type, not both. You have to check against both. But if it matches either of them, then you get the same type attack bonus of 1.5. However, it wasn't working for them. Surprise, surprise, it's because it's an integer, right? And so if you try putting 1.5 into an integer, it doesn't turn into 2, it turns into what number? Everybody? 1. Uno. Very good. Yeah, so if you're ever using decimals, look at that warning right there. Let me move my giant face out of the way. Implicit conversion from double to int changes the value from 1.5 to 1. It'll tell you what's going on. So pay attention to those compiler warnings. They're smart. The only compiler warnings that I ignore are things like unused variables, right? So if I've got like integer x and I just like haven't used it yet, I'm like, shush. I know I have, like, it'll warn you, like, you haven't used that variable. I know. It's like if you were to like try compiling that code, main.cc with all warnings, if you're done, then it will warn you unused variable. I'm like, I know. Chill. Chill. Working on it, And the other variable, the other warning I ignore is foo and x. Like I might stub out a function or something like this, like a little stub function. I haven't written it yet. I'm getting to it. I'm just putting it there so my code will compile. And then if you do that, then it warns that you have a unused parameter. I'm like, I know I have an unused parameter. Shush. I know what I'm doing, And so that, those are the two warnings though that I will ignore while I'm doing development. Afterwards, I'll turn the warnings back on. And I'm like, oh, shoot. Yeah, I did forget. Right? Because if you leave this in here for your final product, your code's wrong, right? Because you meant to be using this variable here, and you didn't. So those warnings are actually good for your sort of like final draft. But while you're doing development, I find them, they just annoy me. They just like, they just clutter up the screen. So I just turn them off while I'm doing development. And then when I am ready for a final pass, I will turn on all warnings. And because all warnings are not all warnings, you need to turn on extra warnings as well as all warnings. And even that is not all warnings either. They're really badly named. I don't know what to tell you. I'm sorry. But yeah, all warnings are not actually all warnings. They were all warnings circa, the 90s sometime. Like that list of warnings became formalized as all warnings. And then they've added more warnings since then. And those are not necessarily part of all warnings. So yeah. So when you're done developing, then yeah, these warnings are like, oh shoot. Yeah, I need to delete that. I need to do something with that. Sure. But like when you're doing development, I find they just like get in the way. And it tells you like the name of the warning right there. And so you can actually do something like this and say no unused variable. Was it no hyphen unused variable? And then that will turn off that particular warning. And we can do the same for unused parameter and turn off no unused parameter. And so this is typically how I compile my code. I typically compile my code with all warnings turned on, and then extra warnings on top of the all warnings, and then turning off these two particular ones because they bug me. Yeah. So you guys understand? That's like a good system for like compiling your code. The compile script, vim which compile with a backtick, you can actually look at the compile flags that I give to you guys, and that's all extra See that? Turning off sign comparison, which I go back and forth on that one. Unused variables, unused parameters. I turn those 3 warnings off. C++ 20 mode, debugging enabled, safe standard library, address sanitizer, and undefined behavior sanitizer turned on. So if you're ever curious, like if you ever go to a different system, then you want to, I can just copy these for you, and you can probably write these down somewhere. These are my favorite compile flags. You can see I've gone through different drafts of them here. I've had many different drafts of my favorite compile flags. So this is my current set that I use when doing development. And so I'll post those onto Discord for you. And basically, that's how I compile my code by default. And when I'm ready to release or something like that, I'll turn on the optimizer. I'll turn off the safe standard library. I start going from safe and slow to unsafe and fast. And that's like an evolution that I go through. So I start off, I do all of my development in safe and slow mode with every safety check possibly imaginable turned on. And then I will sit there and turn the speed dial up and turn the safety dial down, because those kind of move in proportion to each other. The safer you are, the more checks you have, the slower it is. So when you turn up the speed, your safety goes down. Unfortunately, C++ defaults to fast and unsafe. So the defaults are for like experienced programmers. For new programmers, the defaults are all wrong. And that's why I have that compile shell script. That's why I have this list of things here. So I'll put them up on the screen for those of you that aren't on Discord and are watching at home. It looks like that. No, let me get my face out of the way. So G++, all warnings, extra warnings, fatal errors. So it stops trying to compile once it gets an error. Compare debug second. That's a really garbage compile flag. I don't like it very much, but it turns off some of the terrible template substitution errors. I really don't like it though. Fanatic errors will turn minor mistakes that are sort of borderline questionable into actual errors and it won't compile, which is good because you should not be coding that way, in CSI 40 at least. I disable these 3 warnings. Sign comparison is when you compare a signed and unsigned variable. Typically when you have like vector.size and you compare it to an integer. And that's not good practice. You shouldn't do that. You should be using a size underscore t instead of an integer. At the same time, it won't matter unless your vector has more than 2 billion elements in it. So, not in this class at least. And probably even on professional systems, like your vector class is probably going to explode if you have over 2 billion elements in it. Like C++, like the standard library, I don't think is really designed for things that are that big, honestly. You probably want to be using a specialized data structure anyway. So yeah, no unused variables turned off, unused parameters turned off, compile in C++ 20 mode, debugging turned on. This is the safe standard library, which will do things like have the vector class square brackets actually do bounds checking, which normally they don't. And then undefined behavior sanitizer will detect at runtime if you do anything bad as far as undefined behavior. I think various kinds of overflow and underflow will get detected. Not always, though, because some of it is defined behavior technically. So that doesn't trigger that often. It occasionally does. Divisions by 0 maybe might get caught by it, but it doesn't come up that often. But address sanitizer is my boy right here. So that is my boy. ASAN is what it's called. If you take anything with you from this class that and you go to like a different institution, take that with you. That is the god tier compile flag. Anytime you're a student and you're doing development, you need that thing turned on, because when you screw up with a pointer, you knew something, you don't delete it, you delete something, you don't knew it, all those different combinations of like allocates and deallocates, and you mess it up, that boy right there will tell you on line 53 you screwed up and it kills your program, which is good, because traditionally speaking, C++ memory errors are the absolute worst, biggest nightmare bugs to track down, and address sanitizer just makes it as simple as like, you screwed up line 22 main.cc, you screwed up, you deleted that thing twice, and you're like, oh, I did, didn't I? And then you're not baffled and confused anymore, or you forgot to knew it or something, right? It just tells you, it's like, there's your problem on that line, and you're like, cool. Whereas before, students would just sit there and bang their head into the table for 8 hours and just randomly change things until it worked. And even worse, it would work sometimes and it would still have memory errors in it and things like that. So it's very common. The only downside, actually, to Address Sanitizer is the fact that if you run it on other people's code, it will discover 900 million errors. So, because most people don't know about it. That's the really weird thing. It's been around for like, I don't know, 6 or 7 years now, something like that. It's the greatest thing ever. But most people don't know about it, so they don't run it on their code. So when you're using other people's code, like, I don't want to name names here, but other people's code, Address Sanitizer will be like, bloop, 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 you know, and it just finds all these things. You're like, dang it. You know, like, it makes it unusable because other people's code has bugs in it. Yours don't anymore, but, like, theirs do. And you're like, all right. And then you have to file bug reports like, hey, you got a memory leak here. You're doing a double free here, you know. Got to write all these things and hope the other people like fix their stuff. That's the only downside to it. Is that if you're doing it on a big project, if you introduce it on a big project, it will find so many problems that it's like you can't do it. Like the code works, you know, like if you turn it off, it'll work, but it shouldn't be working. You know, so DJ Khalid suffering success. Exactly. Caught so many leaks in a C-site class at state. Right. Yeah. So the professor I don't want to name names. The professor hands out code. Here's your code, you know, make it work. You know, no memory leaks allowed. And his code had like, you know, all these memory leaks in it. So, yeah. So how do you make a special command like compile? There's two different answers to that. One is you can make a shell script, which is what I did. So you can actually just make a file called like, I don't know, doit.sh. What are you waiting for? Do it. Do it now. Do it now. All right. What happened here? Just copy this again. Okay. So you can literally just put a line of text into a text file, and this is called a shell script. So check it out. You have to chmod it. This is the only interesting part. Anybody can read or execute this shell script now, and then if you look at it, it is now an executable. So this line of code, it's not a line of code, this Unix command here, chmod, can make a text file executable. So it's a program. It's literally just a text file. Like if you vim it, you know, it looks like a program, but it's just a text file, right? That's all it is. And so if you say, do it now, it's not going to work because then I'm not passing anything here. You can put in a $0 here. Nope, $1. I always can't remember if they start counting from 0 or 1 on that. And there you go. And so doit.sh is now compiling main.cc. And so this text file here, you can put this again into, scrolled off the top of the screen. You can put this into on any Unix system you want. So Barbarossa, I know you've got your own Linux subsystem for Windows box at home. Just copy that text. I'll paste it in here for you on Discord. No, I copied way too much stuff. Okay. Let's try copying this one more time. It scrolled off the top and copied all that too. So what you're going to do is you are just going to paste that into a text file. And then again, so you're going to edit, you're going to vim the file, put the code in. It's not code, it's a command. And then you're going to do a chmod. Everybody may read and execute doit.sh. And now when you look at it, it is executable. And then you can run do it now on main.cc. And it will compile your code using all of those command line parameters. Another way you can do it is you can set up an alias, which is another thing that I have done for you. And so you can alias G++ to run G++ in C++11 mode with debugging and optimization turned on, things like that. So you can edit your aliases and put in like default command line parameters and things like that. That's in on our system, it's in your .cshrc file. If you're using any normal Unix system, it's probably going to be your bash rc file. I don't use, I mean, I do use bash, but I should use bash more, but I've built up my list of aliases over the years, and I just don't like it. I'm just fixed in my ways because I've got all these different things. Like, so when I type G++ and hit tab, it only tab completes on CPP, C++, CC, CXX, and H files. So it ignores every other file. So like if I made a file called like main dot whatever, and you know, wrote some stuff into it. If I were to vim main, you see, damn it. Maybe it doesn't. Let's see here. Plus, it's supposed to, but whatever. Java C. Yeah. So touch bob dot Java. Touch bob dot Java. Touch bob dot class. And if I Java compile Bob, you notice how it ignores bob.class. You see that? So there's a bob.java and a bob.class. When I hit tab, it doesn't autocomplete on bob.class. That's annoying to me because I would have to type the Java every time. So I have it set to ignore I have it set so that Java C only completes on .java, not on .class files, because that's the only type of file it can take as input. And so it just, there's all these like neat little things like that. So you don't have to keep typing things over and over again. And I have everything like alias down to like one letter or 2 letters for like everything. And so like my workflow is very commonly like edit file, compile the file, one command to run it, one command to edit it. Nothing's more than 2 letters at a time. If I want to go into my homework directory, that is ch, right? If I want to go into the turn-in directory, I can type. If I want to go into the turn-in directory and look at people's source code to see if they're cheating, that's in the turn-in directory. If I want to go into my scripts directory, where I've got all my different programs that push out homework and collect homework, that's 2 letters. Everything's 2 letters. And so I can develop very quickly. And some people are like, well, you could just type 30 letters when you could be typing 2. And it's like, no. I became a computer science major so I could do things quickly and efficiently. Okay, so next up. So that is my advice on like your development environment and aliases and things like that. Next up is your another common thing I saw was int damage is equal to, they have like the power, they have like the attack, and they have like the defense, right? And they would have like int power, attack, defense. And these would be initialized somewhere, right? Like they would, have, they'd be pulling those out of the Pokemon or something like that. What is the problem with this? It's very similar to the stab problem, but it will manifest a little bit differently, right? The problem with the stab thing being set to 1.5 is that it's just always 1, right? So the stab code just doesn't work, right? Like none of the code worked because it's either 1 or it's 1, right? This one is a little bit different. It's going to manifest a little bit differently. We'll say they're initialized, like they're getting set here. I don't want to write out all that code. I'm just trying to focus on the common bugs that I've been seeing in the Pokemon assignment. Round? You could, I guess. Parentheses. It's not asking what Pokemon attack or defense is. That's also in the getting set here thing, right? So like, power is equal to move dot power, and attack is equal to Pokemon 1 dot attack, and defense is equal to Pokemon 2 dot defense. Yeah. Okay, they're set now. There you go. Okay, so what's the problem with this line of code though? Use a float instead of int. Close. So even if we set this to be a float, it's not going to be right. Or you could say double. It doesn't matter. If you want massive amounts of precision for something that doesn't need it, you can use a double. Doesn't matter. Right? And this is a common mistake that students make because they think that if the variable that you're writing into is a double, it will do double arithmetic. And it won't. Okay? It won't. It will not. Not at all. This is an int. That's an int. And that's an int. So what happens? Yeah, you're absolutely right. We can put some parentheses on this. It actually, you'll get different results, but that's not what the problem is, right? So what if power times attack is 99 and defense is 100? What number do you get? So what if power times attack is 99 and defense is 100? What value do you get if you divide 99, an integer value, by another integer value named 100? What do you get? You get 0. That's exactly right. And then this gets multiplied by the type system. It gets multiplied by stab, And at the end of the day, you're like doing no damage. You're like, what's going on here? Like what? Yeah. Why is my type system not working? The problem's not with your type system. The problem is you're doing division. You're doing integer division. Anytime I write a divide sign like that, I stop to think for a moment. I go, do I want to do integer division or do I want to do double division? Right? Like, which one is the right division for the job here? You know? And in this case, you're going to get correct answers actually some of the time, right? Like if power times attack was 200, you would get 2 and it would work. But if you had a power and attack times together equal to 99, then you get 0, and which is completely wrong, right? And so it's one of those frustrating bugs where you're just like, okay, it's working here, but it's not working here, and you're like testing it, you're like, what the heck is going on? And a lot of students will put all of this together into like one massive, like giant, like massive, you know, and it's got like the vectors in there. It's like, you know, vector Bob dot, you know, what do they call it? Pokemon DB, you know. Let's see, that would be the move DB dot at index dot power times Pokemon DB dot at poke one dot attack. Like, and it's all this times this, and there's like, you know, times stab times, and a lot of times we'll just, you know, do the equation for stab in there, but we'll have stab in there times the type system dot add, and then they do like the hash table lookup types, you know, dragon, you know, but that's actually going to be a vector lookup also. Pokemon DB dot at, you know, poke one dot type one parentheses, and it turns into these like massive gargantuan algebraic things. And then you get a 0. And you're like, which one of them 0? You know what I mean? Like, why is it 0? You know, like, there's 900 things on the screen here. Any of them could be the problem. So don't write code this way. Okay? If you have a massive algebraic thing that's not working, it should be split up, right? So instead of doing all that, do something like this. And, you know, see out the damage, right? And the solution, of course, here was to convert one or the other to a double. Habata Feda said, convert defense to a double. It actually doesn't matter whether the top or the bottom is a double. It's going to do double arithmetic if one or the other or both are doubles. And in fact, you can actually write the answer into an integer. That's actually fine because the health is an integer, so it's going to become an integer anyway. So that's actually correct code there. Maybe not if you're going to be like working in stab later. So like maybe that, and then we could say, you know, double times equals the stab bonus, and then you can have double, and each time along, not double, sorry, damage. And you can like see out the damage, right? This is how you should be doing development. Like when you do development, you should be writing a little bit of code and then printing it out and seeing if it works. Because if you write that whole massive algebraic monstrosity and you get a 0, you're just like, I don't know. Like, that, you know, is it my type system? Is it the stab bonus that's 0? Like, why is it 0, you know? And so it's really valuable to just sit there and do a little bit of work, print it out, and then do a little bit of work and print it out, you know? And they do the type system, you know, double type is equal to types, you know, you do the whole dot at, you know, lookup thing using the hash table that we talked about. You multiply that in, you know. Type damage and so on and so forth. So that is basically the right way of doing development, okay? And at the end of the day, you've got the algebra done, you've got a C on the homework assignment already. So, also in the homework, you have to load the type system into a 2D vector. Did anyone, if you feel called out, everyone does it. You know, it's one of those things where like new programmers like typically will like overestimate their capabilities, and old programmers are like, I don't trust myself to add 2 numbers together, so I'm going to print it out. You know, like when I do development, Like I do this much code and I print it out and I'm like, okay, that worked. And then I try it with different Pokemon. Oh, I got a 0 for something. And then I sit there and I can identify it. Like when you write just a little bit of code and you're getting a 0, then you can like zoom in with a laser like focus and print out, okay, what was the move damage? What was the attack? What was the defense? Am I getting a 0 somewhere? And you can, with a laser like focus, like print out the values and you're like, oh, it's a 99 up top and it's 100 down below. Of course, I'm doing integer division. And you figure it out. And it takes you this much time to solve it instead of this much time. And that's, again, what separates new programmers from experienced ones is that we can just find bugs a lot quicker, right? And one of the reasons why we do it is because we actually write less code. Like we write a little bit of code and we test it. And we write a little bit of code and we test it. And that actually allows you to know that the problem is in this code that we just wrote, right? Not this, right? I like every semester I have a student come in with like 100 lines of code written. He's like, there's a bug in there somewhere. I'm like, that's cool, dude. Good luck. no, I help him, but like, it's like, I don't want to. It's like, what have you, where is the bug? I don't know. You're the professor. Find it for me. Like, did you write this whole thing? And, yeah, I wrote it all at once. It's not compiling. It doesn't work. Fix it, and that's not the right attitude you want to have. Okay, so when you're doing development, you really want to work a little bit at a time, right? Like I said, experienced programmers, we don't trust ourselves. We don't trust anything. Like we write code and then we immediately run it and test it. John Carmack, who is like a god among men at programming, he will write like a little function this big, and he's like, I don't trust myself to know enough that this much code will work. And so he will write a function. And this guy wrote Doom and Quake 2 and Quake 3 and Rage and all these massive things, basically, not by himself, but like the engine was really just, he was the primary author on it. Michael Abrash and other geniuses also worked on it, but he's like an incredible programmer. And he'll write this much code and then he fires it up in the debugger and he looks at it and he steps through it one step at a time and he prints the values. He's like, I don't trust myself. I don't think I'm smart enough to know what the computer's going to do. And if John Carmack doesn't, then why do you? Right? That was my takeaway when I saw that interview. I was like, oh, that's a good point. Yeah. Because I do the same thing, except typically I just see out the values and then I just run in and go, okay. He uses a debugger. And that's generally speaking, if you have a big project, you probably want to do that. But write everything in one file instead of multiple. But how do you compile the code if it's not complete? That's what we talked about earlier. You have to like do stubs and drivers and things like that, right? So like if your main has like a for loop and it's like calling some function, like cout, it's calling some function named foo. Foo is like our generic name for function. Like this code won't compile until foo's written, right? And so you have to come up here and you have to write foo, but then you're like writing foo and not main, and you can't, you don't have main, and so you have this chicken and the egg problem. And so typically we resolve chicken and the egg problem. Like, which one do you do first? Both? Now you're writing all 100 lines of code, right? No. So what you do is you will, oftentimes we'll just do this. Like return, like if this is like a D6, like it's a function that will roll a 6-sided die. I'll have it return 4. There we go. And we will now call this function. And so rather than me like writing all the things all together all at once, which is typically what new programmers do, I'll stub it out. This is a little stub function, right? I'll note there's a stub. This isn't the correct answer, right? And now, look, the code compiles. And if I run it, I'm getting 10 dice results that are plausible. I mean, even I could have just been lucky, right? And just gone 4 every time. Like, this is a plausible result for rolling a d6, right? And so what you do is that's how you compile your code if it's not complete. You have a stub function. So any function you call, you're not ready to get to yet. You just have it return some value. Like, how many unique characters are in this thing? 5. Like just, if you have a function that counts how many capital letters are in a word, have it return 3, like whatever. Just, have it give you a number. And then you can work on your code and all the functions you're calling, you just have it return a plausible value. And then you get your code working, and then you later on go in and you fix, things like this. Any place where you have a stub, you fix it. Or the other approach is you have a driver in main where all the main does is call your function. And that's how you do development. That's how you keep your development window. The lines you're working on should be about this big, right? Like if you've filled the whole screen with text and you haven't compiled it yet, you're in trouble. That's that's the Ralph Wiggum, I'm in danger, right? See if I can find. I mean that. It's kind of accurate, but yeah, like the I'm in danger, right? If you have a whole screen of text and you haven't compiled anything, you're in danger. You really are. Okay. So yeah, with a drawing where you sketch out the outline first and you fill it in later, exactly. Like you don't have like if you're an artist, you don't fill in excruciating detail like and just grow outwards, right? You have to make sure the sense of proportions right and all that kind of stuff. There's a lot of similarities there. Okay, so you have the remainder of class today to ask for help. I think that covers everything. Reading the file, you should be able to do that. Were you guys all able to read the type system in? It's like a 2D array. We've been doing a lot of data science this semester, so you guys should be good at reading files. I think better than most semesters. Did you guys get that part? Or like loading the type system in? Okay. Yeah, the other class, that wasn't the hard part for them. The hard part was things like, you know, just like the algebra, right? Like, you know, stuff like that. You know, you have a rounding in there somewhere, and if you make your code too complicated, you can't pull it apart and figure out which piece is not working right. Only one person in the group needs to have it completed. Make sure that at the top of the file you have like partners. Have the list of the partners up top. Have a list of which bullet points you did. The new deadline will be tonight. So I don't like extending deadlines, but given the number of students that failed in the previous class, I'm kind of forced into it. Don't let it become a habit though. So I'll give you guys to like, I don't know, midnight. There, I'll be extra generous. So tomorrow at midnight, not tonight. You couldn't remember how to read into a vector. Okay, I can show you how to do that real fast. So if you have a vector of, are they integers? No, they're doubles, right? Double named vector, let's say. Okay, come on. Part 2, copy type system. Okay, so I've got the type system here. Cool, there's the numbers. It's 18 by 18 if I remember correctly. So we're just going to make this of size 18, and that should be a constant. That's another thing I see a lot of students doing, constant size equals 18. Like they'll just drop an 18, you know, in the thing there, and anybody who comes in afterwards, like, why 18? What does the 18 mean? You know, what is that? You know, like anytime somebody has a WTF, right, with your code, like what is the 18? Why is it 18? You need to have a comment explaining it. Or you can do even better and just be like, you know, the number of types in Pokemon is 18. You know, like this is the better way of doing it. Now there's no WTF there. This is the number of types. And each row itself is going to be a vector of doubles of size types as well. And so this will create an 18 by 18 vector. And make sure they're doubles, not integers, or you are going to be sad, right? And then ifstream ins, opening up type system. We're going to open up the file, and then if there's an error, we'll just like die and be sad. While true, actually it's a fixed size. So should we use while true, or should we use a doubly nested for loop? What do you guys think? We know how many numbers are in there. Maybe. Somebody could have deleted some of them, right? I can see a case being made for both of them. I think that if some of the numbers are missing, though, like the type system's not usable, right? Like if somebody were to just delete some of the entries out, like I don't think we have a good type system like that could work, right? So I think if we ever like came across a missing number or something, we just need to kill the program, right, and just report an error that there's a problem with the type system. So yeah, while for either way, I can see a case being made either way. Int I equals 0, I is less than types, I plus plus, y2y, paste. That's how you do a doubly nested for loop. Boom, boom, boom. Copy, paste. Make sure you change every time you copy and paste. Scan it. Make sure you don't have an I in there somewhere. That was one of your debugging things. You guys remember that one? Where there's an infinite loop? You guys remember that? There's like an I in here or something like that, like I plus plus or something, and then it ran forever. Very common mistake people make. Yeah, you guys remember that from last week or something? Yeah, a lot of people are asking, why is there an infinite loop? I'm like, that's your job to find out. I'm not going to tell you. So that's the homework assignment. Find the infinite loop. How do I do that? I don't know. See out things. See out I and J. You'll find it. Okay, so let us. I think we just do this vec.at_i.at_j. I think this will actually work. I think that'll work. Okay. And then after you read it in, what should you do? So I'm reasonably confident this is going to work. Should I just trust that it works, or what should I do next when I'm doing development? Check it. So one thing I might want to do is just print out like vector.at 8 was that steel type versus poison type, something like that. Like first thing you do is just print out one value, just double check your Pokemon reference card. We're getting a 1. I actually don't know if that's correct or not. Just steel versus poison. Actually, so yeah, yes, you are absolutely correct. Let's just pull this up. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so 8 is steel. And then, which one did I say? 2? It's grass type. So steel versus grass type is times 1. Okay, so we'll try steel versus water. So change this to a 1. And we got 1. Steel type 1 should be 0.5. Unless it's not. Oh, it is a 1 on our system. Okay, never mind. It's correct. Let's try this one then. 0, 1, 2, 3, 4, 5, 6. 6 down, 1 across. That should be a 0.5. And we got a 0.5. Excellent. So what if we had gotten a 0? Let's say that it output a 0 there when we were expecting a 0.5. What should your immediate suspicion be? If you're testing this, you get a 0 when it's supposed to be a 0.5. Yeah, you probably got an int in there somewhere, right? Like somewhere up in here, or maybe you're reading into a temporary or something, and somewhere in there you got an integer, and it's cutting the thing off. Yeah, it's not a dubski, exactly. Int double conflict, exactly. Very good, guys. And so then we'll just go ahead and output the whole thing. So for every const auto reference row, for every row in the vector, for every column in the row. So for every row, for every column, we will see out the column. Ooh, no, let's not do that. See it out with a space, and then maybe a tab. Let's do a tab. Might be too big. And we'll do a new line, right? So after every row is done, we do a new line. Common pattern. And there yeah, it's a little bit too big. I can make the font smaller, but I think we get the point. 1 2 1 05 1 1 1 2 1 05 1 1. Yeah, okay, it looks right. Okay. And in practice, I'd shrink the font and actually like double check, that everything's correct. But do you guys see that approach that you take? Like, you have to have your skills. Like, you'd have to know how to open a file. You have to know how to make a doubly nested for loop. You have to know how to make a 2D vector. Like, you have to have your basic skills down. But it's the development process that stymies most people, because nothing on the homework assignment is actually hard. Like, maybe explore mode, adventure mode, the X credit, sure, fine. But like, nothing on this homework assignment is like hard. Like figuring out the type bonus is like if the moves type matches Pokemon type 1 or matches Pokemon type 2, you get stab of 1.5. Like, that's it. That's an entire letter grade for like 2 lines of code. Like, and the algebra for like figuring out damage is literally just like, math. The only part that might be tricky is like copying a Pokemon out or like searching for the Pokemon based on name or Pokedex number and then adding moves to the person. That could be a little tricky maybe, but it's not really. It's stuff you know already. It's usually the development process that is what gets students, because like there's all this stuff that has to happen, and like they just try doing it all at once and they don't really know, and like things break and they don't know why it breaks. And so this process of like one step at a time, right? And like, like you saw, like right here, like I was getting numbers that I was not expecting. As it turns out, the image that I was using was wrong, but like you go, and then because I only wrote this much code, I could know that I know the problem is in this code right here. It's just this much, right? And so I don't trust myself. I will write 4 lines of code, and then I will spend 6 lines printing it out to make sure it's correct. And then after I'm cool with that, then I will typically do this, and I will just comment it out so that it is in my back pocket, and I can print it out again if I'm ever in need. Okay, please kill me. The basics aren't hard. It's putting together. I test for too much and get lost in the testing. The tricky part is writing a bunch of code and slowly realizing you could have done it in more efficient ways. Sure. And in fact, after you guys have finished this, I will show you. I'll give you a little spoiler. It's like when you have the 2 Pokemon fighting each other. Right, they take turns hitting each other, and so a lot of people have like Pokemon 1 and Pokemon 2, and then they have a speed, like they check the speed, and then they have this giant thing where it does combat for 1 hitting 2 and then 2 hitting 1, and it like jumps back and forth. On my code, Pokemon 2 reference, let's set this over here, main.cc. In fact, you can see what my code looks like here. So I call the load Pokemon DB function, then I immediately like say for every Pokemon in the Pokemon DB, print it to the screen. Right? I load the move DB and I say for every move, and that should be a class reference. Not that it matters, it's just good coding practice. Even though they're commented out, it bothers me. Class reference. Okay, and so you can see I call my function, then I immediately am like, did I do it right? And I print it. And then after I verified that everything's correct, I comment it out, right? So that everything just looks nice, and you don't get to see the fact that, I have to work to make sure my code is bug-free just as much as you guys. Okay, maybe not as much, but some, right? I still check. Maybe I do it more. Maybe I actually check my code more. I don't know. It's an interesting question. Because I don't trust anything I write. That's why I'm always testing and vetting my code and making sure that it's correct. Okay, so let's see here. I'm proud of one thing here. Yeah, all right. So basically, this is how I figure out whose turn it is. So if the Pokemon 1's speed is greater than Pokemon 2's speed, it is player 1's turn. Otherwise, if player 2's speed is higher, Pokemon 2's speed is higher than Pokemon 1's speed, player 1's turn is false. I just have a Boolean, and the Boolean goes true. And then after it finishes, it goes false. And then the other Pokemon goes. Then it goes true again. And The first Pokemon goes, then it goes false. And the other Pokemon goes again. And then if there's a tie, it flips a coin. But this is kind of what I wanted to show you. So I'm actually quite proud of that. So students ask me, like, when do you use pointers ever? Like, non-ironically, right? Here's a good example of it. So Voss, you swap them? Yeah, okay. So Voss, you like the ternary operator. So here you got the ternary operator and a pointer all in one line. Or 2 lines, technically. So if it's player 1's turn, we have the attacker pointer. This is a pointer to a Pokemon. Point at Pokemon 1. And then the defender pointer is pointing at Pokemon 2. And then when player 1 switches, then the pointers point at the other 2. Then they point at the first 2, then they point at the other 2. And so the pointers just go like this. And then nowhere beyond these 2 lines here are Pokemon 1 and Pokemon 2 ever referred to ever again. Instead, it's always through the attacker pointer and the defender pointer. So we can do things like, say, that's actually something I'm proud of. I print out the attacker, I print out the defender, and things like that. So, okay. And so, you can see I'm debugging it. Okay, enter a move. Okay, here it is. Enter name. So we'll choose Bulbasaur. And Bulbasaur will be fighting, what move number to give it? We'll give it like Comet, and Comet's not found. Hyper's not found. Hyper Beam. There we go, it's caps sensitive. Comet, Punch, Hyper Beam, Flamethrower, some sort of Fist. Fist is not found. Flame Fist. What else? Triple something. Twin Needle. Sure, why not? Bulbasaur's going ape up in here. And then enter name for the second Pokemon. We're going to have it fight Mew. And Mew is going to have nothing but struggle. Okay. So there we go. We got Bulbasaur fighting Mew there. Cool. All right. You guys all did that, right? You have the animated. So Mew has a higher speed. It gets to go first. It'll use struggle. It does 50 damage to itself, but it deals 100 damage to Bulbasaur. Bulbasaur dies. Mew's the victor. There you go. Game over. All right. Okay, so now I'm done. Okay, so take the rest of the day. I'll be around. Minkrilla will be around. Any questions you guys have on Pokemon Part 2, let's get you guys whipped into shape. Any bugs you guys got, let's get them solved. Okay, that's it for me today. Peace out. Lab time begins now. Don't just leave. Fix it. Unless you're done, then you can leave. Just tell me that you leave. Or tell me that you fixed it, then you can leave. Or tell me that you're done, then you can leave. But if it's not done and you haven't fixed it, don't leave. Stay. Lab time. Good.